Hello everyone and welcome to the CSD-CrossMiner demo. Today we are going to take a look at a known ligand which binds to a known protein. I'll try to find similar compounds which also bind to this protein but have different physicochemical properties. First of all, I'm going to download a molecule of interest. For this I'm clicking File, Load Reference. You can just press Ctrl+L on your keyboard. I'm selecting the molecule in multi-file format which I have prepared before that, and yeah, there is our molecule. So probably someone could recognize neratinib. Neratinib is a tyrosine kinase inhibitor which exhibits anti-tumor action. In particular, neratinib binds to and irreversibly inhibits human proteins which are called epidermal growth factor receptor, or just a GFR, and human epidermal growth factor receptor 2, which is not a GFR2 but HR2. At a high level, this binding prevents cancer cells from growth and division, which is our target activity. However, no drug is perfect, and now we will try to find another molecule or molecules which can inhibit these proteins too but have different properties and therefore other side effects. We can see that the molecule is not protonated, but this can be fixed easily. I'm clicking on Edit and Protonate Reference. Okay, looks good, looks very protonated and reasonably protonated. I'm going to create a Pharmacophore model of this molecule. I'm not going to cover how this Pharmacophore model is created because its creation is a very challenging task and requires a lot of knowledge and experience and probably a one-year course on this. But here we're just going to build a Pharmacophore model and conduct a search to understand how CSD-CrossMiner works and which results it can give you. To make this Pharmacophore creation process more clear for you, I'm going to label the atoms so you could follow my actions. I'm pressing Shift on my keyboard and left clicking on any atom of the molecule. Then I'm right clicking on any empty space and say labels, label by atom label. So cool, looks very good. Yeah, just for clarity, I'm going to remove hydrogens from our workspace. They will still be there and they will still be bound to the heavy atoms, but we just won't be able to see them, just to make the picture a bit more sparse and clear. Okay, so what we're going to do now, we're going to start creating our Pharmacophore model. For this we need Pharmacophore features, and we'll see that CSD-CrossMiner has a lot of Pharmacophore features. I'm going to make this panel a bit bigger so you can create an acceptor, a donor, projected donor, a ring, a lot of halogen atoms, protein residues, whatever you want. And you can also come up with your own Pharmacophore features with your own Pharmacophore description, but we are not going to cover this in this demo. Okay, let's start and create the Pharmacophore model. I'm clicking on donor projector here. So what happens? CSD-CrossMiner identifies atoms which fit into this description on your molecule and actually highlights those atoms just to give you a hint where this feature can be put. You can actually put the feature where you want to, but CrossMiner just gives you some small hints. I'm going to create this Pharmacophore feature, donor projected, hydrogen bond donor projected, on the NBC atom. So I'm clicking on it, right click, add donor projected. Okay, so we've seen this in our theoretical video. There is a mesh blue surface which actually points to a heavy atom, which is hydrogen donor, hydrogen bond on donor, and we have a solid surface here which helps us to understand the direction of this hydrogen bond. What else do we see here? We see that we have something show in Pharmacophore. We are building Pharmacophore, so we can see this feature that we have added it, and there is the name of this Pharmacophore feature that we built into our model, and there are parameters of the spheres. So these are radii of the spheres, which you can adjust here by clicking changes, but we are going to leave it as default. So I'm going to unclick it just for clarity, and I'm going to move to acceptor feature. So I'm clicking here to see all the hints which CrossMiner has for me. I'm right clicking on atom NBA add acceptor. Brilliant. So we have two features. Great, they are mentioned here. I'm going to add some rings. So when I tick the ring, we can see that there are 4 of them highlighted, but we need just 3 of them. I'm selecting this one, right click, add ring, right click, add ring, and one more time here. Okay, I'm almost done here, but there is one important thing that I want to add to my Pharmacophore model to make my Pharmacophore search more specific, and that's chlorine atom. I'm clicking on it. There is just one of those, and right click, add chlorine. Great. So it looks like a really good Pharmacophore model, but there is one more thing I want to add, and that's intro constraint. If I press this button here, intro, I let CrossMiner know that all of this Pharmacophore feature are coming from the same molecule, not from small molecular protein, but yeah, whether it's protein or small molecule, but just please keep it in one molecule. I can also save my Pharmacophore query. This is it. I'm clicking on the file, then save Pharmacophore, or you can just press Ctrl+S on your keyboard, and I say Pharmacophore, and it will be saved in the .cm file, and we have already seen that it's just a set of Pharmacophore features which are included into the Pharmacophore query with their parameters. Okay, save. Alright, so we don't need this panel anymore for now, and we are going to take a look at the databases here. So as I have already mentioned in the presentation, we have PDB-CrossMiner, nucleic acid CrossMiner. These are structures which come from PDB, and PDB has binding sites of ligands or cofactors with their proteins with resolution filter set to 3 angstroms, and nucleic acid and CrossMiner have nucleic acids in the structure and have a more loose 3.5 angstrom resolution filter. CSD-545 CrossMiner and those 2 add-ons to this database are structures which come directly from CSD. For this specific search, I will need PDB-CrossMiner only for the sake of speed, so I'm unticking all the other databases. Yes, great. That's what we need. I'm going to make this panel smaller because we need this panel where our hits and the search results will be shown. One more thing to show you before we start our search. I'm clicking on Edit and Options. These are advanced search options, so I'm keeping them as defaults now because it perfectly fits to our needs. But yeah, please change these numbers only if you are sure that you know what you are doing, because these options are a bit advanced. But long story short, it allows you to understand what's the balance between the search speed and search quality. Alright, so I'm going to untick first in cluster here, and I will tell you what it means a bit later. And yeah, I think that we are all set and we can run the search. To run the search, I'm clicking on the play button on the top panel of CrossMiner. And see, we can see a lot of hits that we have found. And if we scroll down here, yeah, there are plenty of those. Some things to show and know about the interface of CSD-CrossMiner. We can see something which is called cluster here, and I've removed the tick from here, first in cluster, and there is a tick color hits. They are all connected, and let's tick on hits here. Whoa, we have a rainbow here. What it means? CrossMiner can clusterize molecule by their similarity. In particular, it uses Tanimoto similarity, which is a similarity based on the structure of molecules it clusterizes. Each cluster has its number and its color, helps you to visualize how diverse your results are. So, for example, you see the blue one, that's a SOT cluster, that's this one, and you can see that molecules there are quite similar. So, and if you actually want to focus on the diversity of your hits, you can just click on first one cluster and see the average representative of each structural cluster. Okay, what else we can do here? I want to sort my hits based on the name. So I'm left clicking on identifier and see the molecules became sorted by the name. Let's click on this first hit. That's 1XKK structure, and yeah, looks very similar, and that's actually a molecule we could expect, and that's a very good result because this molecule from 1XKK structure is lapatinib, and it has the same anti-cancer activity but has a bit different profile and a bit different pharmacokinetic properties, so it's used for treating other types of cancer. And if we scroll right here, we can see that there is annotation of the structure, and we can see that yeah, it binds to GFR kinase domain, which is good, which is what we have expected. One more interesting structure to look at is let me scroll down, is 4I24 here. So we can see that it's quite similar. It doesn't have a ring here, and it has a bit different tails from our original molecule. But this molecule is dacometinib, which is also an anti-cancer agent and which helps in treatment of other types of cancer, different from those where lapatinib and neratinib are used. Okay, so what we've done here, we have found some molecules. We can actually save those we like. I'm going to take these two we have talked about, and I'm clicking on File, then say Save Marked Hits. I can do this in Mol2, I can do this in SDF, or I can do this in CSV with all the annotations I have. I actually prefer just an informative CSV file and say results. Okay, looks good. And the last but not the least thing that I want to show you, which makes CrossMiner really special. So I'm going to throw away all our results, clicking on the bin. I'm also going to close reference, left click file, close reference, and I'm also going to close our Pharmacophore model, left click on file, and close Pharmacophore. Brilliant. So imagine that you really want to investigate the question of cross-reactivity, and the information you have is a protein binding site. So you can actually search through the protein binding site, and if it comes from PDB, that's even better because it's already built into CrossMiner. What we can do, we can click on feature database here, then we can go browse, and what I'm gonna do, I'm going to select the binding sites from a structure of interest here. Let's make it simple, and that will be 1xKK that we have already seen with lapatinib. I'm going to click on use as reference, and it gets to our workspace, and you see that those features that we have there, acceptor and rings, they are highlighted, and actually CrossMiner doesn't see any difference. It highlights those features in both ligand and the protein. And what you can do is actually create the Pharmacophore model of your binding site and run the search through PDB database or your in-house database and find which pockets are very similar and where you can observe the off-target activity. Okay, so there was an example of application of Pharmacophore Search. Take a look into the molecules of your interest and try to find something new and unexpected in your research. Thank you.